Hello, everybody, and thank you for joining today's webinar. We've got a fantastic lineup featuring Mike Johnson, the lead data scientist for Lockheed Martin, Greg Forrest, the senior manager of AI AIM Labs for Lockheed Martin, Chris Kowalek, senior manager of AI systems at NVIDIA, and Thomas Robinson, the VP of strategic partnerships at Domino Data Lab. Today we'll be telling the story around how Lockheed is powering their rocket science initiatives with data science. If you have questions during the session, feel free to post those into the Q&A window at the bottom of your screen, and we will follow up with a recording of today's event after it's over in the next few days. With that, I will turn it over to Mike.
Hey, everybody. Thanks again for joining today. So Greg and I are super excited to talk about what we're doing at Lockheed Martin. So I'll hand it off to Greg, and he will walk us through some intro on who Lockheed Martin is. So
thanks, Mike. So good morning, everyone. Thank you for joining us online today. Appreciate your time. So again, my name is Greg Forrest. You heard Mike. I'm joined by him today. He'll be my co-presenter, and you'll hear from him a little bit more in just a few minutes. But just a quick background on us. So Mike and I are both positioned in Lockheed's Chief Technology Office. So that's within the corporate division within Lockheed Martin. And I currently lead our AIM Labs team and the AI strategy development for the enterprise. And Mike is one of our lead data scientists, and he's providing solutions to our many external customers and internally within the business. So he's focused on solutions that make Lockheed Martin as an organization better, faster, cheaper. And it's some of these use cases that you'll hear about today, and specifically how Domino and NVIDIA have made our team, have given us the ability to deliver these capabilities both to our customer and internally. So when Mike and I were first approached by Domino to do this, we immediately jumped at the chance. So we felt really compelled to tell the story about how both Domino and NVIDIA have served as partners and allies for us in what I'll say is really a continuing journey to deploy AI at scale across our business and to our customers. And I think that's really the key here, the at scale piece. At Lockheed, right, we want to be the global leader in supporting our customers' missions, in strengthening our security, and advancing scientific discovery. And so our customers primarily, but not exclusively, are the United States government. So we work for the Department of Defense, the Department of Homeland Security, Commerce, Energy, State, et cetera. A whole bunch of government agencies, including NASA as well, the intelligence community, and what we call the S&T community. So these are the science and technology communities. So you can think of organizations like DARPA and AFRL. And so I just wanted to explain a little bit about who we are, right? So we're a pretty large company. We've got around 110,000 employees worldwide. We operate in 54 countries across the world. We've got about 375 plus facilities. And the reason I'm saying all this, the key with this is with all of that scale, there are many strengths within our organization, but that scale also produces many challenges. Challenges like scaling AI across a large organization that's geographically dispersed. And that challenge is very similar to what our customer faces as well, right? So when you think about our DoD customer and the different armed services, they're up against a pretty similar challenge as well. But what excites me the most about this particular chart is the number that's in the upper right-hand corner, right? And so about half of our employees are scientists and engineers, which I think is really, really cool. And one of the things I wanted to speak about very quickly on this chart, and Mike won't speak to, is, through both Domino and NVIDIA's Deep Learning Institute, we are working tirelessly to upskill this population and provide them with the skills and the resources necessary to become what we would consider within Lockheed to be, like full-fledged data scientists within our organization. And as we look at our strategy and how we are going to scale in the future, building that ground up organic capability is really important for our organization. And we partnered with both Domino and NVIDIA to do that. And so the training aspects and some of those services that they provide have been really critical for us. So Lockheed Martin business areas, right? So we're divided into kind of 4 different business areas that are focused on different things. So we've got our aeronautics division, our key product out of there that's probably most recognizable is the F-35. We have a missiles and fire controls division. RMS focuses on the rotary is the Sikorsky aspect of our business, and helicopters like the Black Hawk, and also avionics and mission systems. And then lastly is space, right? And my my favorite part there is kind of the human and the deep space exploration piece to that. And so I talk about kind of our business because we see AI as absolutely critical in advancing a lot of the key technologies, almost all of them, that are pertinent to all of these business areas. And we also work across a lot of different domains. So this is, land, air, sea, and space, right? And so there's a lot of technologies that are critical to these areas, like advanced comms and 5G, mission manager, sustainment, and there's a myriad of other technologies that support what we call joint all-domain operations. And AI is going to be critical in delivering these required capabilities to our customers. So what does that mean? With the breadth of what we do across all of these business areas comes data types that are incredibly vast. They're differentiated. They run the gamut of, for example, the electromagnetic spectrum from, what we call EO, electro-optical, so camera, computer vision, to IR, to time series data coming off complex assets like ships and airplanes, and then all the way to internal business operations data. Like every company, right, we're trying to do better internally, right? So how do we squeeze out more efficiency with every dollar that we spend? And so all of this necessitates the need for an MLOps framework and a pipeline that can ingest different data types. And so this goes from, the need to label data through model training, through deployment, productionization, test. So V&V is really critical to our customer. How do we validate and verify that what we're putting out in the field is performant, it's safe, it's ethical? And so these are all really important aspects of this MLOps pipeline that we're working to build. And we'll explain how NVIDIA and Domino are a big piece of that. And so with all of that as well, we need to do this with tools that are compatible with modern software best practices. So, for us, that's the DoD's DevSecOps requirements, right? They're going to a heavily, container-based approach, right? With container orchestration tools like Kubernetes. And so when we think of our MLOps pipeline, all of this needs to align with our customer's vision and how they're implementing their DevSecOps processes. And we need to kind of put all of this together. And I think if anyone saw Dr. Will Roper's presentation at the DoD AI Symposium a couple weeks ago, I think he laid this out really well when he talked about his vision to push code, right to the edge. And for us, the edges are things like ships and satellites and airplanes. And know that when we do that, it's going to be performant, it's going to run safely. And so these are all really critical aspects to what we do. And so Domino and NVIDIA have been key components to this broader MLOps framework that has enabled us to bring DevSecOps best practices to machine learning. And so specifically, Domino allows for ease of access to technology. They've allowed for repeatability of research and experimentation, and Mike will go through some of those examples. The ability to collaborate has been really critical for us. And lastly, the ability to leverage GPUs at scale. So Mike's going to talk about a program called AlphaDogFight. These are primarily reinforcement learning algorithms, and they required a tremendous amount of GPU resources to actually go and train those reinforcement learning algorithms. And Domino and NVIDIA have given us the capabilities to go do that. And so in general, in a lot of cases, we've actually seen 100x improvement in efficiency gains in data scientists at Lockheed being able to get started with machine learning. So, a couple of years ago, before we had Domino, it was, it took an intern, for example, like 8 weeks to actually just get access to a GPU behind the Lockheed Martin firewall. And now it's just push button. And it's those savings added up, across thousands of employees at scale that really make the difference. And so that's enough of me. I think, Mike, I want to hand it over to you and talk about some of the really cool use cases where we've used some of these tools. We've actually delivered value to both, external customers and internal customers. So thanks everyone for your time. And Mike, I'll hand it over to you.
Awesome. One of the things I like to do is talk a little bit about how we think about machine learning or, artificial intelligence, at Lockheed Martin. And I think that there is a misnomer about how this process works. And so there's a bunch of folks out there that think that you take a data set, you sprinkle some AI pixie dust on the data set, and you print $100 bills, right? You just print business value all day long. And the reality, I think, is both more nuanced than that. But I think it's actually a better situation for the humans who are actually doing and performing the machine learning. So in reality, the very beginning of a machine learning project is starting with identifying an interesting outcome. That interesting outcome could be predicting when a particular machine on the factory floor is going to need maintenance. That interesting outcome could be predicting what cash flow you're going to have on a particular program. It could be predicting the trajectory of some incoming ballistic, right? So there's a huge variety of different things that you might be interested in terms of outcomes, right? So if you advance one. So the next step in the process is really to identify and collect data. And so I'll talk you through 3 use cases today. So you'll get a sense of some of the variety of data that we have. But one of the key things that we look for in performing this process is something that can integrate an extreme variety of different data types. We have almost every database under the sun. We have basically every data type under the sun. And we really needed a machine learning platform that could support that. So the next step in this process is really training and validating a model. So you've got your data and you need to go train a model. In this case, that often requires getting access to large amounts of compute, whether that be high memory or multiple GPUs. And we'll talk a lot about the deep learning work that we've done here. So access to compute is critical, but also this is an iterative process that typically involves multiple people. So repeatability was really a critical aspect for us. One of the things I'd like to say is, the best model, the finest tuned, most sophisticated architecture, most beautiful thing that sits on your laptop on a command line is meaningless, right? And really can't get you to the business value that we need to realize out of these machine learning solutions. And so having the ability to quickly and rapidly deploy a model or deploy an interface to end users so that they can interact with the model is really critical to our success at Lockheed. And I'll talk a little bit about that. And then the next step is really monitoring your model, right? Once you've got this model deployed, how do you actually keep track of how it's performing and so on and so forth? So these are all critical components. And this is a simplified view, but I think it's a lot richer than this concept of sprinkling AI pixie dust. What I'll do now is walk you through 3 different use cases where we've really used the power of Domino and NVIDIA together to bring value to the business. And the first is supply chain. So what you're looking at here is the Orion Crew Module. So for human spaceflight, this is targeted to go to the moon in 2024, so it's pretty exciting. And one of the things you'll notice is that the number of different unique components that come together to build something this sophisticated is immense, right? Lockheed Martin has one of the largest and most sophisticated supply chains on the planet. And there's significant amount of risk to these large programs for one very specific part not being able to be supplied on time, right? And so understanding and getting our heads around supply chain risk is really critical to our success as a company. So in this case, what we did was, we have a pretty good understanding of the risk that we know about, right? Internal risk with different parts and schedules and so on. But we wanted to get some exposure to supply chain professionals around open source risk. So what sorts of risk can we deduce out of open source unstructured data, right? So an example is this, one that we've got on the slide where there's a merger between 2 large Lockheed Martin suppliers. And this has implications on our supply chain. So this could have implications as we're going into contract negotiations. It could have implications on how we actually run our business operations. Like, are all of our part numbers going to change to a new system, based on some consolidation of IT systems for our suppliers? Or is this an impact to business stability, right? So defining risk in this domain is complex. There's a lot of different facets. So what we chose to do was really surround risk on all sides, right? And so as we start to get into the technological solutions, the first thing we wanted to do as we're looking at this unstructured data is apply a category, right? So this is like a classic classification model. In this case, we want to understand, hey, are these documents about merger and acquisition? Are they about bankruptcy? Are they about a significant management change? If so, that holds higher risk than documents of other categories, right? So the next step is, are they relevant to Lockheed Martin? So is the item being discussed relevant to our space in defense and aerospace, right? And so we've got models that sort of tell us that. And then the next step is to understand, hey, what's going to happen in the future? Can we get some eyeballs on what's going to happen next? So for example, is this company likely to go bankrupt within the next 15 months, or are they likely to have some financial loss or something like that? And we combine this with our extensive internal knowledge of our supply chain to really create a sense of risk that supply chain professionals can actually respond to. So you get to the AI. So this is the AI we built. This was quite a challenge, right? So we needed to create models that could categorize documents, that could assess relevance, that could do predictions. And we needed to do this with really effectively no training data, right? And so that, forced us to look at, hey, we need a system that allows us to access and do inference on pre-trained models. So this could be like the Spacey library. We also needed to do a lot of transfer learning, right? So when you start with very little training data, you need as much as you can get off the front. So being able to have the amount of compute that's required to go fine tune these large-scale transformer architectures like GPT-2 and BERT was really critical, right? And then being able to deploy interfaces so that we could have the actual active learning loop in there, so that we can have human feedback on the different, ways that the models are performing was pretty critical to our success, right? In addition to that, we've got a lot of different people that are contributing to this overall project. So one of the solutions that we put together used a combination of hybrid rules, and you can think of these rules being collected by subject matter experts, augmented with machine learning. So having a system that's flexible enough to design these custom solutions was pretty critical. And then we also needed to include several creative training sets. And I've got a whole nother talk on what those are. It's kind of fun. But the ability to kind of keep track of that data and assign it to these projects really made this project a success. So the next use case I want to talk about, Greg already mentioned, and that's the AlphaDogFight project. So this was a competition hosted by DARPA. And the focus was to build trust in artificial intelligence across the DoD, right? And so the idea here is, can we develop a system that can compete with humans in the, within visual range air combat maneuvering space, right? So think of planes fighting each other like Top Gun style, right? And so, the way that this was structured was it was a competition among many teams. Lockheed Martin was one of the participants. And there was sort of a trials between each of the different AI participants. And then at the end, some of the top competitors were able to sort of go up against humans who were sort of expert trained in this F-16 simulator. Obviously, solutions that can operate in a space this large are complex to build. And so the Lockheed Martin team took a hierarchical reinforcement learning approach, which involved training multiple agents to operate and sort of specialize within different domains of the dogfight. And this is a huge compute need, right? And so the team that worked on this was able to use Domino to some significant success. So each of the agents that were trained, each of these hierarchical agents, took on the order of 30 days. And so if you can think about the number of different experiments that you need to do and the size of space that you need to explore so that you can be competitive in this domain, we really needed to rely on the ability to do parallel training on like DGX size machines and the ability to spin up multiple jobs, right? And track those experiments through, through the Domino interface, right? So this really resulted in, a 10x larger hyperparameter search to explore, which was was critical to the success of the team. And the onboarding, you can't minimize this, right? So instead of having to go provision a bunch of resources for new people, get them set up, get them their own Docker containers, and push everything out, it's really push button. So you can go from taking days or weeks in some cases to becoming productive on a project like this to actually onboarding new folks in minutes. And in this particular project, we were able to see that through. In this case, Lockheed Martin got second out of the trials, which we consider a great success, and they were actually able to defeat an instructor who trains people to use this F-16 simulator. So this was a really good success for DARPA and a really good success for Lockheed Martin as a whole. Okay, so the final use case, again, to give you guys a sense of the different variety of data that we think about and deal with, is Internet of Things. So Lockheed Martin, sort of as a part of their digital transformation, has a significant investment in IoT framework. So this is the F-35 line, and you can imagine this is a building that's about a mile long, and at the beginning of the building is raw materials, and at the end is F-35s, right? It's like one of the most impressive things I've ever seen. And you can imagine the number of different machine operations that happen in the space of creating an F-35, whether that be drilling or autoclaves that sort of set the materials up, or painting. There's a lot of machines involved in that. And one of the use cases that we have is, can we build a system that can continuously monitor those machines for potential issues, right? Can it notify us when the machine is misbehaving? So we used, Domino Data Labs to build out a system at a really significant scale with a relatively small team, right? So we built a system that does, we're taking like an ensemble approach of deep learning models. So there's a huge variety of different models that we've got in the system. And so we need to train on NVIDIA GPUs and deploy on inference a huge number of models, right? So far, we're really in sort of the prototype phase, but so far with the system that we've developed, we've trained over 250 models, and we've had over 150 of those deployed at the same time, right? So that means right now our capability is we can monitor over 5,000 signals. And, some of the machines that we monitor are super interesting, right? So if you look in that lower right-hand corner, that's one of our large TVAC chambers that we use for like full vehicle test, in space-like conditions. It's a 20 by 20 chamber. You can see like the little people. And we have that connected to our IoT system, and we're able to monitor as we're doing these high value tests, what's going on, right? We've been able to, do 74 million inferences. And those inferences take from the time that the machine is connected to the time that we have inferences written in. You can see this little dashboard in the upper left-hand corner. It's a Grafana dashboard. It takes 5 seconds, right? And a key part of that is us using the Domino ecosystem and the flexibility that we have about spinning up resources for both training and inference into, in this case, like a Kafka pipeline for doing real-time inference, right? And so, the team that's working on this is only 2 or 3 machine learning engineers, right? And so the amount of work that we've been able to get, because we don't have to go build out all the infrastructure and get access to all the compute and manage all that, has been, absolutely incredible. So that's it, for us, for our side of this presentation. I think, again, sort of underlying those points, this combination of Domino and NVIDIA is absolutely critical for us. We do a significant amount of deep learning, and the ability to have like that AI software, this, ecosystem, right? Brought together with Domino, with the ability to spin up all of this GPU resource. It really has gotten us, to the next level in our machine learning maturity.
All right. Well, Mike, that was fantastic. Mike and Greg, thank you both. Hello, everyone. My name is Chris Kowalik, and I'm a senior manager of AI systems here at NVIDIA. And I just want to tag on a little bit of what Mike and Greg said there and give you a little more context for how NVIDIA sort of fits into the picture there, and how it might be able to help you as well with your deep learning, machine learning, AI workflows. So when you look at NVIDIA, a lot of people think of us as, sort of our heritage as a video game company. And of course, we've grown to be so much more than that. We really pioneered the use of accelerated computing for AI. And we did that not just with the realization that the GPU is a really fantastic hardware device for doing AI, machine learning, and deep learning because of its ability to deal with thousands of parallel computations at the same time. But the next step was being able to take that really powerful hardware device and actually make it easy for people to use to be able to do their AI projects on. So that involves something that we invented called CUDA-X, which is basically a programming layer that allows you to take this GPU that, again, was originally devised as a graphics processing unit and use it in these AI workflows. And then that GPU and that software on top of it, we've taken it even further and gone into optimizing all of the machine learning, deep learning, AI frameworks that people use, things like TensorFlow and PyTorch, so that they can take full advantage of the power that the GPU offers. And then it's available across this variety of different product lines. So that really gives you a lot of different places where you can get yourself involved in using machine learning, deep learning, and AI using GPU acceleration, starting with our RTX cards, through our partner systems, our DGX systems that Mike mentioned, our edge systems, and so on. So there's a lot of different places where you can kind of on-ramp onto the NVIDIA ecosystem to be able to take advantage of this GPU-based acceleration for doing your AI workflows. But a lot of people, because of the ubiquity of the NVIDIA GPU, a lot of people start on something as simple as an NVIDIA GPU-enabled laptop. So maybe even a GeForce gaming laptop. A lot of AI happens on GeForce gaming laptops. It's pretty amazing. And even standard business laptops, a lot of them have NVIDIA GPUs. So that's really where the spark of innovation comes from, whether that's for an individual project or an individual engineer who's trying to get into AI. It's not really that difficult to get yourself something where you can start experimenting and doing work. And you can also do that with a cloud instance too, right? It's not very hard at all to go online and get a NVIDIA GPU-enabled cloud instance for a few bucks an hour and experiment. But as you start to grow into actually doing projects, you're probably going to want, again, like Mike was talking about, sort of a multi-GPU system to be able to train larger data sets and being able to have a lot of different options about how you manipulate that data and how you train your model and work with your model. So you end up buying these multi-GPU systems or graduate to larger cloud instances that have multiple GPUs, maybe trying to hook them together. And then as projects start becoming more successful in your organization, you find that other teams now want to use AI in their projects too. So the organization ends up buying more systems. They end up buying, more GPU-enabled systems or get more cloud instances, and you end up with this sort of nest of AI projects that aren't really coordinated and aren't really taking full advantage of the resource investment that the organization is making. And that's when you're in need of production infrastructure. And this creates a couple of things. If it grows organically like this, it's not a bad thing to certainly start on laptops and to move up as your success increases. But you end up in this situation where you have all this different hardware that you've acquired, and there's a lot of design guesswork to try to make those things work together. And a lot of deployment complexity as well, trying to troubleshoot things, making sure that the storage system is working with the computers that you bought and the networking is appropriate. And it actually can get pretty complicated pretty quick. And then all of this complexity leads to a complex workflow. And that's really what we're focused on here today. We have some customers that prior to using solutions like Domino were doing things like they were scheduling the use of their systems via Slack. So they'll send a Slack message to a team that has a GPU server with 8 GPUs and say, hey, can I use 2 GPUs for the next 24 hours? And they would schedule their jobs that way. And it's just really, really inefficient when you don't have on-demand access to a complete set of all of the resources that you have available in your organization. And really what we're trying to do with all of this is to increase iterations. And again, Mike mentioned this again too, this idea that if it takes 30 days to train something, obviously you can't iterate very quickly on it. So you start making a lot of concessions. Either you lower the size of the data set or you try fewer hyperparameters. You do a lot of things to try to speed it up. But instead, we feel that you can apply the NVIDIA platform to this and reduce these red sections of that circle so that you have more iterations that can happen in a reasonable amount of time. A lot of times, a lot of projects, they end up training overnight. That's kind of a common workflow. As you work on your model all day, you kick it off before you go home for the night, or nowadays you kick it off before you go into your living room and leave your office or your bedroom. And then you wait and you see what happens, and then you come in the morning and you look at it, see if you got the results you wanted, tweak it, do it all over again. But if you can reduce that by whatever factor it is, we saw 30-to-1 on that factor on that slide earlier. If you took something that normally took 5 hours and you reduce that to 15 minutes, all of a sudden you're getting many, many iterations a day, and the overall quality of your model increases significantly just because you can get more experimentation done quicker. And the basis of all that in the NVIDIA world is the NVIDIA A100 Tensor Core GPU. So we announced this earlier this year, and it's really a marvel of engineering. It's a 20x leap in performance in processing AI neural networks over previous generations. And it's the largest processor the world has ever made. So this GPU is also not just for training. It's actually designed for training, data analytics, and inference. So it can do every type of AI workload that you might need, which really helps you be able to create an infrastructure that is adaptable to whatever your entire organization is doing at that given time. You don't have to have separate siloed workflows for training, for inference, and for data analytics. So in our DGX A100, which we announced at the same time, we have 8 of these A100 Tensor Core GPUs, along with a lot of other very powerful components in this system. This is really the building block of the modern AI data center. You can put this in a data center and use it standalone, or you can scale with this DGX A100 to thousands of systems if you have to. Some of the largest supercomputers in the world are using a large number of DGX A100 systems, including one called Selene, based here at NVIDIA. And you can connect these together with high-speed NVIDIA Mellanox networking and be able to train the largest models that you could possibly imagine. And if you're working on smaller projects, be able to do those projects much quicker, as we talked about before. But then as you start to get more of these things, like I said, it can get a little bit complex to try to figure out the right storage, the right networking, the right configurations for all these things. So we provide something for free on our website, something called the DGX Pod Reference Architectures. And these are developed in conjunction with top storage vendors to be able to give you a prescriptive set of instructions for designing larger multi-system deployments that involve multiple DGX systems, storage from several different vendors, and networking, and how to configure all that so that things work properly. And this is what really solves that hardware part of the AI infrastructure problem, and actually, into the software layer, all the way up to the point of the actual workflow that we're going to talk about in just a second. This gives you a platform for doing accelerated machine learning, deep learning, all encompassing AI in a singular platform that's pretty easy to manage and pretty easy to deploy. But once you've solved that, you've solved the design complexity issue, and you've created kind of a centralized AI resource for your organization, how do you provide access to that resource? And that's kind of the key thing. These folks that are doing AI want to be able to have on-demand, immediate access to GPUs and not have to do the Slack-based scheduling that I talked about. And this really, it speeds your workflow, it increases productivity, it helps you scale. You don't have people reserving systems. This is something we run into a lot, where someone will just have a system that they use periodically and they need access to it when they need it, but when they're not using it, it's sitting idle. And obviously you don't want to do that from an expenditure perspective. So this helps you maximize and utilize your infrastructure with this great tool from Domino. So we call that, or the industry is really calling that ML Ops. And so that's about kind of merging the sort of machine learning side of things along with the sort of DevOps ideas of helping these teams work together to be able to maximize workflow. And this really gives you simple access to your compute resources. And it helps you create this AI center of excellence where you have a top tier hardware platform managed by a completely easy to use system to be able to get the most out of that platform. And Domino is certified under something we call the NVIDIA DGX Ready Software Program. And that ensures that Domino has been tested to work on clusters of our DGX systems, small clusters, large clusters, and ensures that it's going to work for you in your environment. Okay, so coming up very soon, we have our GPU technology conference. It's called NVIDIA GTC. It's coming up October 5th through 9th. It's online. And this year, we're focusing on public sector with our NVIDIA Public Sector Summit. So you can go and sign up for GTC and see a number of fantastic sessions across all kinds of different areas, again, with this focus on public sector. Now, GTC is where we bring together hundreds of NVIDIA engineers who can give you really in-depth presentations about how to do machine learning on various types of systems. We go into a lot of detail. There's a lot of heavily scientific content, a lot of, and there's some higher level strategic content for how to look at things. So there's lots of really great things available for you on online GTC. And you can see here that there's several sessions from Lockheed Martin and Domino Data Lab as well. And I think Mike and Greg, or maybe just Greg, is doing one of these sessions. So you'll get several folks that from Lockheed who can give you a lot of information about other projects that they're working on as well. And then Domino is going to go into talk about some other information there too. And you can also sign up with the Domino's code at the bottom of that screen there and get a discount for the online GTC. And that's it for me.
Yeah, Chris, it's a great opportunity to explore additional use cases and go a little bit farther in depth than what we did today. So there's some really cool presentations that we have teed up. So I'd invite everyone to check it out.
Thanks, Chris. I'm going to dive into our Domino section here. So at Domino, our mission is to unleash the power of data scientists for organizations to address the world's most important challenges. And one of the things that Mike and Greg alluded to here is scaling data science in enterprises is really hard. We see a couple of different problems. The first one being infrastructure friction. So I think you heard plenty about this, but the inability to get access to compute resources, especially GPUs, getting all the tools you want in order to do the most advanced research possible is always a challenge in large enterprises. The second piece is lack of knowledge management. We see a lot of organizations repeating the same work over and over again, or working in silos where different people are doing the same things or don't have the opportunity to cross-collaborate in some of the work that they're doing. And the last piece that we see are production challenges. So we do all this fantastic research work, but unless you actually ship a model out to production, it's not really reaping the benefits of that research work that you've done. So today I just want to double click a little bit in infrastructure friction and say some of the things that we hear. I love the anecdote from Lockheed about the interns that took 8 weeks to get access to GPU machines, but it's among many different problems that we see from people. Maybe you're lucky enough to get a large GPU machine provision from your IT department, but 6 months later it's full of cruft. You got different versions of Python. Nobody knows how to use it, or as Chris alluded to, you're working via Slack to try and get access to it during a certain window during the day. Practically, just to make this kind of real for people, a lot of times as a data scientist, instead of jumping into research work, you end up staring at a console and thinking about all the DevOps work that you have to do in order to get started. So Domino, we're an open data science platform, and what we do is sit above that traditional compute or NVIDIA GPU resources, and we provide self-service, scalable infrastructure, reproducibility, and collaboration. We help with the model ops, so publishing those models to production and monitoring them, and allow for governance and reporting. And this means you can take any tool or workload from your organization, whether that be Python, R, or MATLAB that you're writing code in, whether you're using scikit-learn or Anaconda or TensorFlow, whatever sort of package you want, we bring that into Domino to help orchestrate. And then we allow all the users in the organization across many different groups to be able to leverage the same platform to use together. What this means is instead of that doing DevOps or MLOps, we're no-ops. We make it super easy. And I like to think about that in 3 steps. We basically allow a user to choose the environments with the tools they want. So this is maybe an NGC container from NVIDIA or Domino Analytics distribution or something custom you've made. And then second, you choose the hardware you need. So this could be a single GPU or a multi-GPU instance, or a carving of MIG instances on the DGX A100. And then you're up and running. You're working in a notebook. So here we have a Jupyter Notebook, working on that powerful machine and doing your research immediately. So in the background, Domino's doing a ton of work for you. First, we're allocating compute resources and however many you need. We're laying down all the tools, libraries, IDEs you want to use. We're connecting you through the browser to that compute instance. And then once you've finished your research, we save all your work automatically. We keep a record of the configuration, all the code and data you've used, so you can easily repeat any of your work. And then finally, we clean up the environment to allow others to use it and to free up the resources for the organization. So at Lockheed, as we talked about, this means we power hundreds of data scientists, thousands of projects, and tens of petaflops of processing power, and make that readily able for people to use. And so when organizations use Domino, we see them centralizing their data science work, and that has a couple of benefits. For data scientists, it gives you ready access to self-service compute to do your research and development. Second, for data science leaders and teams, it means you can see all the work you're doing in one place, share past work. Finally, for IT teams, it alleviates the headache of needing to govern these powerful resources, and gives them access to control audit usage, monitor resources, while still enabling data science teams. So great. Karina, I'll turn it back over to you.
Thank you, and thanks everybody. We got a bunch of good questions coming in through the Q&A. The first one that came in that I believe Greg over at Lockheed is interested in addressing live is, where does machine learning stop and AI start for Lockheed?
Yeah, so I think we do use the terms interchangeably. However, there is a differentiation, right? And so, from a machine learning standpoint, any algorithm that's learning via data, right? And so that's all the way, random forest, and I'll say non-deep neural net architectures, all the way through. We think of AI as more of the non-deterministic, RNN, CNN, scans, things that are more deterministic. But in general, I'd say it's they're tightly intermingled, and we do use the terms interchangeably within the organization. Obviously, they're just different methods in using data to solve problems and ultimately predict something and infer something about the world using past data.
There are a couple questions that came in around like what cloud infrastructure Lockheed is running, and whether Domino is connected to AWS, SageMaker, other data science tools.
Yeah, right now we're an AWS shop, so we use the AWS GovCloud pretty heavily, and there's a few questions about SageMaker that I can answer in terms of our own personal experience. We do have some folks that use SageMaker, but overall, we've really seen the flexibility of Domino. I think people tend to lean towards Domino as a way to build, train, and deploy models versus doing the same work in SageMaker. It just gives you a little bit more flexibility, and you have to deal with a little bit less AWSing. So
great. How do you get access to all of the data within your company, considering it's technical / export control / DoD type data? Is it all integrated via Domino and NVIDIA, or do you use another enterprise data integration tool?
If somebody wants to come help us solve the data integration problem, I'm just kidding. Access to data is for legacy, like large companies born by acquisition. Data access, data silos are huge. So we've got an entire organization that's actually dedicated to helping us break through those barriers. One of the things that we need from a machine learning platform is the ability to integrate a very large number of data sources versus having to, for example, ingest all your data into one spot, or something like that. And that is some of the flexibility that Domino gives us. We probably have 20-ish connections to different flavors of databases and within that, maybe hundreds of connections to individual databases. So that's a huge problem for us that we need to solve as a corporation. And on the machine learning side, it's really about flexibility.
Yeah. And yeah, just to reiterate Mike's point, right? That is certainly one of the largest challenges we face in trying to scale. And so when we think about the whole ML ops pipeline, the whole left-hand side, data integration, and how we actually bring all of that to bear across the organization is something we're really focused on. And then even through, things like labeling, having common ontologies for labeling across the organizations, these are all, standards that we're working on, so we can do things a little more seamlessly, right?
And this is a good one. How did Lockheed make the transition from custom tools to an enterprise platform like Domino? What did the journey look like internally? Did it happen with existing staff, or did new hires bring in the transformation?
We had several folks who had the vision that we needed a enterprise platform. We went through a pretty extensive trade study. Yep. Before we selected Domino, and a lot of the features that we're talking about were those key sort of areas that allowed us to select it. In terms of actually going through the transition, you saw what Greg put down in terms of 58,000 engineers. We have a huge number of folks at the company who have a very, very strong appetite for applying machine learning in their domain. And so it's been a relatively smooth transition for us in the sense that the alternative, the concept, that Chris talked about where people were slacking, scheduling different jobs. That was reality for folks who wanted access to GPUs, going through dealing with port forwarding and setting up, going through PuTTY and, setting up different remote connections to servers and like all of that stuff, all the overhead goes away. And so it's been a pretty easy thing for us to grow pretty quickly at the company because it really, the way I say it is, it really gets all the stuff that you don't want your data scientists worried about out of the way. And that's been the critical thing for us. And it's, onboarding for even like experienced data scientists, like I don't think I needed any training. I just basically got on the tool and started pushing buttons, and I probably pushed a couple of the wrong ones, but it was a pretty smooth thing for us. So
yeah. I'll say overall, our philosophy on tool selection on things like Domino is we let best of breed come to the top, right? And so it's really easy to turn user after user after user onto the platform and let it grow organically. And I think that's really the best indication of how easy it is to use and the benefit that it's providing. And so, we let the user base around the corporation tell us. And we've gotten some really great signals across the enterprise that this is a great approach. And so we do that for all the tools, right, in the pipeline. And so it's going, right. It's taking on a life of its own as users get access to the platform.
All right, probably our last question. Do you use a lean approach in your IIoT unsupervised learning training?
So I'm trying to figure out exactly what we mean by lean approach. I will make a plug though. I am doing a talk about our unsupervised anomaly detection at GTC. Coming up. So if you are interested in that, please take a look at, it's that bottom one, building an enterprise streaming analytics platform. And so, that's, come to that talk and ask me there. So.
All right. I think that's about it. That's all the time that we have. Thank you all so much. We appreciate it.
Thanks for having us on today. Appreciate it.
Yeah, appreciate it. Thanks.
Thank you.